Example 4. I like example 4b. I like example 4c. I like example 4b. I like example 4c. What I really mean is I like where there's a different normal force than just mg. So let's talk about this. It says find the maximum force of friction between the mass and the ground for the following objects. In other words, how hard would you need to pull to get these to start to accelerate? Technically, we're finding static coefficient of friction. So this is a job for a free body diagram. Cody, what are the forces acting on this? Get the obvious one, which is mg. And are we sinking into the ground like quicksand? Are we flying into you like Superman? Okay. And then it wants me to find the force of friction, the maximum force of friction. I'm not going to add it to the diagram. I'm just going to calculate it. How do I find friction? Friction is what times what? Good. I don't know the normal force. Oh, but look. I don't know the force the same size as a normal force. Which one? It's going to be mu mg. Friction is going to be, what's mu? I don't know what's mu with you. 0.35. I got that just from the picture. M8, G 9.8. Cody, what'd you get? And give it to me to all the sig figs. 27.34? 27.44? Okay. Come on, Ben. All right. How is diagram B different from diagram A? What do you notice? Yeah. There's an extra vertical force. If you ever see an extra vertical force in a picture like this, normal force is not mg. This is going to be much tougher. So let's see if we can do this. It still Annie, are we right? 1.4? Yeah. Let's do this next one. What are the forces acting on it? Get the obvious one. Okay, that's not going to change at all. Are we sinking into the ground like quicksand? Are we flying here like Superman? So there's going to be a normal force pointing up. I'm going to tell you right now, it's not mg. Here's the question. Is it bigger or smaller? Why bigger? Because normally the normal force is just canceling out mg, but now it's canceling out mg and an extra 55. So I'll really exaggerate it so it catches my eye. I often will go like right through the next line so I know something's different. There's the normal force. I'm going to see if I can do it right here. Friction is what times what? Actually, I'm going to do it down here. I know what I'm going to use that up here. Friction is what times what? Good. That hasn't changed. And up until now, I've said, I don't know the normal force. Oh, but look. This one's a little tougher. I can't just, oh, but look. Instead, are we sinking into the ground like quicksand? Are we flying into it like Superman? What that really means is all the forces down have to equal all the forces. What are all the forces down? There are two of them. mg, and that sounds like a plus sign, 55, has to equal all the forces up. There is just one of them. So the normal force is not equal to mg. You know what the normal force is equal to? mg plus. So wherever I see Fn, what can I replace it with? mg plus. So in this equation down here, there's going to be a mu, and then in brackets, mg plus 55. Because friction is still mu times the whole normal force. What's mu? I don't know what's mu with you. Still 0.35. And then it's going to be 8 times 9.8 plus 55. So there's going to be a question on your test and on not the quiz that you're writing, but probably the next quiz where the normal force will not be mg. It'll be obvious. There'll be a clear vertical arrow pointing up or down on the diagram. What'd you get, Carson? 46 point. I think that's right. Is that right? If I was going to 3 sig figs, 46.7, but I want to carry all the digits just for this one, for a reason. Okay? What does that mean? If you push down on something, it gets harder to slide. Why? Because the object got heavier? No. Which force got bigger? Normal force gets bigger. So yeah, pushing down on something is not the way to slide something. Okay? Okay. What about situation C? This is a job for a free body diagram. What are the forces acting on it? Get the obvious one. Gravity. What's weird about this? Cooper, do you see there's an extra 55 Newton force pointing which way? So the normal force is not going to be mg because there's an extra vertical force. Is the normal force going to be bigger or smaller than mg? Yeah, in fact, 55 newtons smaller than it normally has to be. I'll exaggerate it, yoink, so it catches my eye. Now, this question didn't say find the normal force. It said find the force of friction, the maximum force of friction. So I'm still going to start out, Cooper, by saying, okay, friction equals mu times the normal force. And I would still say, I don't know the normal force, but I'm not going to go, oh, but look. I'm going to have to do a little bit of math. Cooper, are we sinking to the ground like quicksand? Are we flying through the like Superman? Everything down has to equal everything. What's everything down? Good. What's everything up? Two things. What are the two forces pointing up? More specific as a number, exactly. Yeah, okay. So over here, I'm going to say gravity has to cancel out normal force and the 55, or normal force and the 55 are canceling out gravity. I want to get the normal force, Cooper, by itself. How would I get the normal force by itself? How will I move the 55 over? What is the normal force the same as? mg minus 55. So what can I write instead of the normal force? And I'm going to do that over here. Friction is going to be mu mg minus 55 in brackets. In fact, you can probably just backspace on your calculator and edit and change the plus sign to a minus sign, and you're probably good to go. It's going to be less than 27.44 because I know that when we were just moving it without pushing up or down, it was 27.44. I don't know what you're going to get. Annie, what'd you get? 8.19? So what does that mean? To get situation A accelerating to the right, you would need to pull with more than 27.44 newtons. What about situation B? What would you need to pull more than? Anderson. Good. Oh, 0.69. What about situation C? As soon as you pulled harder than that, they would start to slide and accelerate. Oh, and because there's technically two different kinds of coefficients of friction, you could ease up a little bit, but we're going to pretend that doesn't happen. I told you we'll just pretend there's just one coefficient of friction. Keep that easy. Is that a hand up? Oh, no. Okay. Oh, we got a visitor coming in. Pause for a second. Example 5. For each of the blocks below, write a vertical force equation. Find the force of friction, write a horizontal force equation, find the acceleration. You know what? I'm going to draw a line down the middle of the page. I'm going to do these simultaneously, kind of like that. Jordan, what does part A want me to do? You know what I should do before I even start writing any equations? What might this be a good job for, Jordan? I'm going to do a free body diagram. You're going to talk me through that, and then I'll let you ease up again. No problem. We got this. So it looks like the two situations are fairly similar. There's friction for both of them. There's a coefficient of friction of 0.12. We're pulling with 20 newtons. Looks like in the right-hand situation, we're pressing down. Okay, I'll deal with that. Meanwhile, what are the forces acting on this 10-kilogram mass? Get the obvious one. I totally agree. What else? Bigger? Smaller, or the same size as mg? I think in this case, same size. What else? What do I call that 20 newtons coming from off the page, the mystery force? What label have we given that just for convenience? We called it F something. No, F net is the winner minus loser equals what MA. And we called it F applied. So I'm going to draw an arrow to let myself know that I saw it, and I'll write F app. Do they want me to include friction? How do I know? Because they gave me a coefficient of friction, so they're saying assume it's not ice. Which way will friction point? To the? And I'm going to assume it's a little bit smaller than F applied. If I get a negative acceleration, I'll find out that I guessed wrong. Jordan, let's do the right-hand one. What are the forces acting on it? Get the obvious one. Which way? Yep. What else? Bigger? Smaller? Or the same size as mg? You know what? Not the same size because there's an extra vertical force. Bigger, yeah, you know what? Because mg's having to cancel out, sorry, the normal force having to cancel out mg and the 15. I'll exaggerate it so it's stupid obvious. What else? Which way? What else? Yeah. Here you go. You can go back to sleep now. Jackson, what does A say it wants me to do? Vertical is this direction. Basically, if you're sitting on a surface, it's everything down has to equal everything up. So in the first situation, the vertical force equation, what's everything down? Don't overcomplicate it. What's every force pointing down in the first picture? Yep. What's everything up in the first picture? Or you could have written Fn equals mg. Same thing. Ooh, the second situation, a little bit trickier. What's everything down? There's two things. And? Yes. Don't overcomplicate it. Yep. Mg and the 15 has to equal what's everything up. Good. Okay. Lauren, what does B want me to find? Well, friction equals mu times the normal force. And over here, friction equals mu times the normal force. Okay, let's go back to the first diagram. I don't know the normal. Oh, wait a minute. Actually, Jackson was clever enough to give me an equation for the normal force. When he wrote a vertical force equation, he said the normal force is the same as what, Lauren? Yep. So I can go equals mu mg. Let's crunch the numbers. Let's see. It's going to be friction equals, what's mu? I don't know. What's mu with you? 0.12 times 10 times 9.8. I can do this in my head. It's going to be 10 times 9.8 is 98. 98 times 0.12. It's going to be 9.8 plus 1.96. 10.8. 11.76. Lauren, double check me. Am I right? Is that what I said? Woohoo! 4 sig figs, baby. Right-hand one's going to be a little bit trickier, I think, because it's still going to be mu times the normal force. I don't know the normal force, but it's a bit... Oh, wait a minute. Jackson, what did you tell me I can replace the normal force with? What's it the same as? Okay, so it's going to be mu, and then in brackets, mg plus 15. It's going to be... What's mu? I don't know. What's mu with you? 0.12, and then in brackets, 10 times 9.8 plus 15. Do that one in your head, Mr. Do. Oh, maybe. Sure, I can. 10 times 9.8 is 98 plus 15. It's going to be 108 plus, it's going to be 113. 113 times 0.12. It's going to be 11.3 plus 2.26. 11.3. 13.3. 13.56, Lauren, I think. Ooh. By the way, you may have noticed I occasionally like to show off that I can do math in my head. On a test, I will do 1 plus 1 on my calculator. I will do 2 plus 2 on my calculator. On a test, I will never try doing math in my head because the number of times that I've gone 2 times 3 is 5 or something dumb like that where my brain confused addition and subtraction and I didn't catch it. So I'll show off in my homework. I'll try and take shortcuts in my homework, but coding, never on a test or a quiz. Never. So hopefully you're finding we approach homework and assessment, quizzes and tests differently. I've scrolled down. C. Hannah, what does C want me to find? Sorry? Oh, horizontal force equation. Look at the picture. Horizontally, who's winning? Who's losing? What does winner minus loser always equal? And what about the right-hand diagram? Who's winning? Who's losing? What does winner minus loser? Oh, is it the same equation? It's the same tug of war. I think the values are going to be different. But it is the same tug of war. Cooper, what does C want me to find? Sorry, what does D want me to find? Sorry? What does D want me to find? Oh, how would I get the A by itself? We should call that a theorem, Cooper's theorem, I think. So I think what you're telling me, Cooper, it's going to be F applied minus friction divided by M. Yes? Okay. I've scrolled down. How big was F applied in the first diagram? I think they told me. Was it 20, Cooper? Okay. And then friction, I actually calculated in B, 11.76 divided by, what was the mass? Do that one. Oh, yeah, I can do that in my head easy. It's dividing by 10. 20 take away 11 is 9. Take away 0.76 is going to be 8.3, 8.24, 0.824. Double check me, Cooper. Or I might be wrong, but I think I'm right. Like I wrote just there. Meters per second squared. Okay. The right-hand side, Cooper, what do they want me to find in part D? In fact, I think it's going to be the same equation, but we're going to input different values. It's going to be, again, divide by M using Cooper's theorem. Oh, I wrote friction first for some dumb reason. It's going to be F applied minus friction all over M. This time it's going to be 20. Friction was 13.56 all over 10. And of course, I can do this in my head. It's just dividing by 10. Be 20, take away 13 is 7, take away 0.5 is 6.5, take away 0.06 is 6.44. So 6.44 divided by 10, you're probably going to get a 0.644, I think. I think. No, it's 0.644, I'm sure. I thought I made a mistake dividing by 10. That I can do. I noticed a few of you not typing at all. You know who you are. You probably want to make sure you're typing these to make sure you can type these in. In a couple of days, next lesson, it's going to get way more complicated because we're going to be doing with multi-mass problems. So it's going to be more than one mass, and they're going to be ugly fraction over ugly fraction. But if you've been following along, it won't be too bad. Next page. You don't need to memorize any of this, but anytime I show you a new concept, I like to try and give you an idea, Hannah, of what's really big and what's really small. So here's some common μ's, some common coefficients of friction. Wood on wood is about 0.25. Steel on steel is about 0.5, which isn't great. Oh, how can we make steel on steel slipperier? What do we do? No, we don't sand it. That would be terrible. Polishing is different from sanding, but there's something basic that every machine has that you take for granted. Your hint is look at the next one after steel on steel. Steel on steel, what do we do? It starts with the letter L. Yeah, we add lubrication. And the reason is we're dropping the coefficient of friction down and dramatically reducing friction and therefore extending the life of the parts. Yeah, you would not want to sandpaper it. That would make it rough. Polishing it would make it smooth, but better yet, just add some lube. We have also, there's an entire industry around that, right? Lubrication, it's the main reason in the last century why whales were being slaughtered, because that was the best lubrication technology that we had at that time, was using the blubber and turning that into kind of a whale oil. Very, very good lubrication until we came along with synthetics that are better. Rubber on dry asphalt, anywhere from 0.4. This one varies. When is pavement the most sticky? When it's really cold or when it's really... Okay, this one varies a lot. On a hot day when you can feel your bike tires or your shoes are almost sticking to the pavement because they're almost getting melty, that's about 0.75. But standard pavement around 0.4. What do you notice, Hannah, when it gets wet, when it rains? And so my message to all of you is, if it's raining, it'll take you twice the distance to slow down or more than you're used to. It's nothing to do with how good a driver you are. When it rains, please slow down. Just slow down. Can't argue with the physics. Rubber on ice, that's why it's really tough to walk on ice with sneakers. Steel on ice is also really slippery. Skates. Okay, all these values are approximate. Can you have a coefficient of friction greater than 1? Rubber on glass has a coefficient of friction of about 2. What that usually means is it will support its own weight against gravity. That's why those little rubber decals, you can stick them onto a window and they'll stay there. Okay, friction is enough. Pulling it down, gravity's pulling it down. Friction is more than enough to overcome gravity. Insects that crawl on walls typically have a coefficient of friction higher than 1. Example 6, a dragster tire has a coefficient of friction of 0.28. Shouldn't a tire with so much friction slow the dragster down? Using principles of physics, explain why a high coefficient of friction is essential for racing. And it says, hint. Lena, what's the hint? For example 6, put your phone face down, kiddo. What's the hint? What does it say in brackets? For example 6. Draw a... What is FBD an abbrev for, folks? Okay. Here's the dragster. Lena, what are the forces acting on it? Get the obvious one. Which way? Yep. Is it sinking into the ground like quicksand? No. Is it flying here like Superman? No. Are there extra vertical forces? I think we can safely assume the normal force is the same size as mg. Let's pretend forward is to the right. So which way do we want this dragster to accelerate? To the right. So everybody draw a big arrow pointing that way. And here's the question. What force is it that makes a dragster accelerate? What is it? Yeah. Yeah. Oh, Lena did it. Lean. Friction is what times what? From your formula sheet, you got it. I think you're right. I think I heard you saying it. Friction equals, right, mu times the, we're on the front page, fine. We're going to be on the front page for a while now, where it says F net equals MA, and then it says weight equals mg, right next to that, mu times the normal force. Okay, we can't change the normal force. We can't add, we could, but we can certainly, as mu increases, friction increases, and so the acceleration increases. Any of you watch drag racing on TV or been to a live drag race? What do they always do right before the race? Why do they do a burnout? To impress the crowd? No. What's stickier, hot melty rubber or cold rubber? They're increasing mu on the tires right there. They know the physics. They're getting the rubber hot as well, so they're actually bumping up the coefficient of friction a little bit more. Yeah, that's part of the strategy. It's also why drag racing is so expensive, because you go through tires really fast. Many reasons why drag racing is expensive. Okay. In real life, don't write this down. If we're going to be completely accurate, though, there would be air resistance in that direction. Don't write that in. Because if the question doesn't say include air resistance, pretend it's not there. But also, have you seen what dragsters look like? They're pretty aerodynamic. They've thought of that, right? Example 7. I think I have what? 1, 2, 3 more? Yep. We watched the video already last class. A force of 120 newtons is needed to push a box along a level road at steady speed. This is always a key phrase I would underline. What does steady speed tell me in terms of physics? I would even probably write that above it. And if A is 0, what do I know about the forces? They must be, I'm looking for a word that starts with the letter B. Okay, we just picked up a lot of information from that phrase. The force of gravity on the box is 250 newtons. Okay. Ryan, what does A want me to find? Don't write this next bit down, look up. Look up. My first thought, Jordan, would be, don't write this down, friction equals mu times the normal force. And then my brain would make the noise like when they scratch the needle across the record to show everything has come to a stop. That, why won't that work? It's pretty obvious. Don't. What? Loud and proud, Cody. No mu. I would start there and my brain, So I wouldn't even bother writing that. I would have done that in my head first. Now we'll pick up our pencils. So now what? We pivot to another strategy. You know what this might be a good job for? What are the forces acting on this box? Get the obvious one. What else? Bigger, smaller, or the same size as mg? Good. What else? Which way? Let's call it to the... When in doubt, have stuff moving to the right, because that way all of our pictures look the same. So let's put friction pointing to the left. What else? Yeah. In fact, how big is F applied exactly as a number? It's 120. Am I going to draw F applied bigger, smaller, or the same size as friction? Why must it be the same size? Steady speed, baby. A is 0. Okay. I'm going to write F app. And you know what? Since they gave me numbers, I'll put the 120 there, and I'll even put the 250 there. Okay. Ryan, what do they want me to find in part A? I don't know the force of friction. Oh, but look. I know another force the same size as the force of friction because we're at a steady speed. What force has to be the same size as the force of friction? And how big is F applied exactly as a number? So how big is friction exactly as a number? Now, to get you to see that little chain of reasoning has taken a while. And I hope you're going, oh yeah, that makes sense. So there will be a time once in a while where they'll ask you friction. You can't find it from the equation. You can figure it out from the free body diagram. So friction equals F app. That's a terrible app, Mr. Dueck. Is 120 newtons. Okay. Sorry, what's B asking me to find? Well, I only have one equation with mu in it. Which one? Read it to me. Friction equals, get the mu by itself. How would I move the normal force over? What's the normal force doing to the mu? So you're telling me yet another equation, mu equals friction divided by the normal force? Ooh, Ryan, I know friction. How big was friction in newtons exactly? I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. How big, Ryan? Oh, but look. Oh, spoiled my punchline. I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. How big exactly in newtons? I know. Okay? I don't know the normal force. Oh, but look, 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 look. I don't know the force the same size as a normal force. How, what? Were you way overcomplicating that? Yeah, okay. That's never happened with you before. What do you get? Is it 0.48? Dividing by 25, you times by 4 and divide by 10 is the cheap trick. 0.48? Units. There are none for the coefficient of friction because it actually would be newtons divided by newtons. They would cancel. No units. But as far as I'm concerned, now it's fair game for me to ask you to find a coefficient of friction. Hey, what's mu? What's mu? This next question, I like this question, but it's got some teeth. I would consider this a solid B plus A minus level question. Read along with me, Dina. A 500 kilogram, 540 kilogram dragster's tires accelerated from rest. Probably I would underline that to a speed of 48 and a distance of 64. I'm already thinking to myself, I might need to use kinematics to find acceleration because we're in forces land. Oh, okay. Evelyn, what's A asking me to find? Yeah, it's asking me to find the acceleration. I don't think I'm going to use, don't write this down. I don't think I'm going to use Cooper's theorem because I don't think I have the net force. In fact, what's B asking me to find? The what force? So B is asking me to find the net force. So I think based on from rest and all that other stuff, you know what, Evelyn, I'm going to go A equals question mark. What does from rest tell me? Yeah. Old familiar territory. What's that 48? What's that 64? Yeah, probably a displacement, but I think we're going forward, so everything's positive, so we're good. Looking for an equation that's got an A, VI, a VF, and a D in it. There is one. I think it's the squared one. Get the A by itself for me, kiddo. Minus VI squared. Would you not minus it over? Right? All over. Now, the nice thing is, you would have got away with it because VI is 0, so plusing 0 squared and minusing 0 squared, no one would have noticed. But let's keep going. 48 squared minus 0 squared all over 2 times 64. Get that one in your head, Mr. Well, maybe I can. Oh, yeah, because it's going to be an 8 times 8. That's going to cancel out, so it's going to be a 36 on the top divided by 2. Is it 18? Which is about good for a dragster. A little under 2 Gs. That's probably what they're pulling right when you step on the gas. Okay. Got this. Angus, what's B want me to find? The what force? The what force? That's our trigger word. I can go straight to F equals what? Did they give me 540? Did they give me, oh, I just found A. So it's going to be 540 times 18. 9720? Is that right? Yeah? Lane, wake up. That's right? Units? Yep. Hey, that little wake up, that's on YouTube. Or it will be. You're a celebrity now. C. Okay. Jada, what's C want me to find? My first thought is always friction equals mu times the normal force. I should probably do, oh, did they tell me mu? In fact, you know what D is asking me to find? Okay, so if you wrote that down, just do that for now. What's our pivot? What might this be a good job for then? Let's try that. So here's my dragster. What are the forces acting on it, Jada? Get the obvious one. What else? Yeah, and you'll notice I'm giving you less hints as we're doing our free body diagram. That's going to continue, so I'm not doing the we're sinking to the ground like quick. I'm letting you figure it out on your own. Good. Same size as mg, yes. What else? Which way are we accelerating? To the, let's say to the right. So which way does there have to be an unbalanced force? To the right? Right? Hey, which force is that? Yes. And there is no force pointing to the left. Okay. Who's winning? It's pretty obvious. Who's losing? It's a trick question. No one. It's like elementary school sports day, right? Winner, no loser equals MA. Now, why is that so nice? Pause, Jada. What did we find in part B? MA. So you know what friction equals? 9,700. And by a fluke, when we found the net force, the what force? The net force, that also turned out to be friction, since friction is the only force horizontally. You've all been very patient. We're almost done. Maya, what's D want me to find? What's mu? I don't know what's mu with you. Oh, I only have one equation with a coefficient of friction in it. It's this one. Get the mu by itself. Friction, 9,720. I don't know the normal force. Oh, but look. I know the force the same size as the normal force from my free body diagram. Which one, Maya? You tell. You know what? Let's be bold and go straight to our calculator without even writing in the M and the G. What did I say M was? 540? So it'll be 9,720 divided by, in brackets, 540 times 9.8. And this one I can't do in my head. What'd you get? 1.81? Which is above. Oh, no. Is this a dragster? Did we just say dragster tires tend to be really, really sticky? Okay. I'm okay with that. 1.81. Anybody else? 1.83? 1.84? You didn't round? You chopped off? So what was it, Maya, who did this correctly? Hopefully the last two questions, Dina, I haven't really taught you anything new. We've just been a little bit clever, but this is tying into what we've already done. So we're looking at some applications for car racing. I have one more. Tomorrow, we're going to press pause. We'll mark the take-home quiz. I'm going to give you a lot of homework from today's lesson, but it's going to be working on it tomorrow during class. Okay? Is Wednesday a Pro D Day? So I'm trying to set things up so you don't have too much homework on the Pro D Day, but I don't care that much, even though it's going to be sunny. I'm really aiming to give you your long weekend in May fairly free. That's my goal. I like example 9. I like example 9. Example 9 is the next question. This I would consider a good A-level question. Okay. So, Davin, what are they asking me to find? Neil, what's me with you? What might this be a good job for? They gave me a picture. What are the forces acting on this? Get the obvious one. What else? Bigger, smaller, or the same size as mg? Spoiler alert, it's not the same size. It's going to be smaller because we're lifting up with 85 newtons. Okay. What else? What's that 75? Oh, I even told you. F applied. I'll draw an arrow just to let myself know that I saw it. What else? Which way? Looking for where this starts. Yeah, left. And, ooh, wait a minute. What direction are we accelerating according to this question? So which force is going to be bigger, F applied or friction? Okay. Yes? I guess it must be slowing down. Who's winning? Don't say F applied, Davin. Good. Who's losing? What's that always equal? What are we trying to find? Which of those three has a mu hidden inside of it? Let's get friction by itself. I need to move the F applied over. What's right in front of the F applied? No, what's right in front of the F applied? Okay, this is not going to be a swappy dance because I'm not trying to get the F applied by itself. I'm just going to plus it over to get friction by itself. And I'll get friction equals MA plus F applied. Yeah? Friction is what times what? Mu, you say. Oh, let's do that in our next line. Let's bring in mu times the normal force. That equals MA plus F applied. Davin, what did you say they want us to find? How would I get the mu by itself? How will I move the normal force over? I don't want to rewrite this whole equation. Dina, are you okay if I go chunk, chunk, chunk? Okay. Let's do a check before we go to our calculator. Do I know M? Did they give me the mass? I've scrolled down. Did they give me the mass? Good. Did they tell me the acceleration? Did they tell me the applied force? I don't know the normal force. Oh, and I can't go, oh, but look, it's the same size as mg. I'm going to walk back up here, and I'm going to write on a, you know what? I think you're seeing it, but it's everything down has to equal everything up. So everything down is mg. Everything up is the normal force and the 85. Yes? And I'm going to put that in the bottom of the fraction. So I'm going to scroll back down. Hey, I can fit this all on one page. So it's going to end up being MA plus F app all over mg minus 85. Mr. Dueck, do the m's cancel? No, if there was an m in all four terms, they would cancel, but there's only one m on the top and one m on the bottom, and the other two terms don't have an m. I've talked a lot. Let's see if we can go straight to our calculators without writing out the numbers. So if you have the fancy schmancy fraction button, use it. Otherwise, is there more than one thing on the top? Bracket around the top. Davin, I've scrolled down. What was m? What was A? Plus, what was F applied? Close off the top, divided by bracket. M, you said, was 20 times 9.8 minus 85. I got a typo. Did you get 0.891, 0.891 repeating, or am I wrong? Ollie, you got that? Yeah? You did it differently? Okay, show me later. There's other ways to get there. I'm doing the lazy but organized method, right? Are you crunching numbers ahead of time and plugging in the numbers? I usually try and do everything in one fell swoop on my good calculator that I advised you all to get. Is that right? Is it 0.891? Repeating, but 0.891? That's fairly sticky. That would be really, really good rubber shoes on hot pavement on a hot day. Stickiness. Angus, roll your eyes at me. No, yeah, come on, you got it. Oh, ouch, that hurt. Anderson candy for you. Oh, and no units, coefficient of friction is this weird unitless ratio is what it is. Okay? What's your homework? The take-home quiz for sure. We already watched the baffling balloon behavior video a couple of days ago. So you can try number 1. Number 2 is good. Number 3 is good. 3 is so easy that it's tough. 4 is good. 5 is good. 6 is good. I'm probably going to assign most of these. 7 is good. Yeah, 8 is good. 9 is good. 10 is good. Yeah, 1 to 10. But you're going to get all class tomorrow after we mark the quiz. And there's still 15 minutes today. A lot of you are still working with homework from lesson 5. The dragster question that we did today, that free body diagram of friction winning, nothing losing, that's handy for some of the questions from lesson 5. I think number 5 and 6 and 7, it's all a very similar free body diagram. Thank you very much for your patience.